Good afternoon. Thank you for joining the webinar today. I'm Bethany Maddox, and I'm a Customer Care Specialist at Vitech. Zane Scott will be our presenter today, and Zane is our Vice President of Professional Services. We're happy to answer any questions on or offline, depending on the nature of the question. We'll have some time for Q&A following Zane's presentation, so please type your questions into the Q&A box in the GoToWebinar panel. We'll be monitoring the questions during the presentation. So without further ado, I'll hand this over to Zane.
Good afternoon and welcome everybody. I'd like to thank our host Bethany and our recording engineer Laura Heineck for their help in putting this on, and I welcome you to this presentation. What we're going to talk about this afternoon is something which is of concern in many organizations, and that is that the systems engineering functions and groups are not living up to the potential for their organizational contributions because they tend to get shuttled into document management, a function that becomes like a librarian or an auditor, pushing documents back and forth among the people who are doing design work, and are not able to have the value to an organization that they should be able to do. We're going to talk today about using model-based systems engineering to leverage your systems engineering functions and groups so that the organization is truly empowered by systems engineering. We're going to do this in three parts. The first part, we're going to talk about what the issues are. How do we wind up disconnected? In what senses are we disconnected? We'll talk about a few scenarios under which systems engineering is forced to be suboptimal in its contribution to the organization. We'll move from there into an overview of model-based systems engineering concepts, and we're going to do those at a very simple level. We'll do that for a couple of reasons. One is that the true power of systems engineering, and especially model-based systems engineering, is a very simple concept. It's the power of that concept lived into your systems designs and systems solutions. So we'll be simple in our treatment of the concepts, and also we want to be able to connect with folks who have not necessarily lived the systems engineering life for a great deal of time. If you feel like you have an understanding of systems engineering and that's a little simplistic, I apologize, and in the very next breath encourage you to return to that simplistic foundation, because it really is the basis of the power here. And then finally we're going to talk about how we reconnect that with the organization to take advantage of systems engineering at its highest potential. We'll cheat a little bit. Everybody remembers your high school algebra book where the answers were in the back. Well, we've taken the answers and moved them up to the front. So here are the concepts that we're going to present this afternoon and the subjects that we're going to talk about. The first is that model-based systems engineering empowers through wisdom. That means that the real power here comes through the insight and the knowledge about the system in which your problem resides to begin with, about the system that you design in order to deal with the problem, and about the system as improved once you're implementing your design. It's the knowledge about those systems that really transmit the power here. The second principle I've already touched on, and that is that model-based systems engineering is really a simple concept. It becomes very complex, and we use it to manage complexity, but at its heart, it's actually quite simple. The value of the model comes from exercising the model, from the ways that we use the model, and we're going to talk about several different roles that the model plays as we begin to leverage systems engineering to empower the organization. And we're also going to talk about integration as a conversation. The integration of all of the domains of systems engineering, the integration of all of the concepts, the integration of the model into one really is a way of having a conversation. It's a conversation between your project or your program management and the systems engineers and the test and evaluation folks, and back and forth in combinations. Model-based systems engineering is simply a way to have that conversation that gets out of it the greatest part of the value that you can possibly get. Why is this so important? In today's world, systems are becoming more and more complex, and the stakes are higher and higher. Here sits a guy in flight control, the air boss on an aircraft carrier. Imagine all of the systems that have to function flawlessly and in synchronicity around him. Complex systems with very, very high stakes, and the world is tending in that direction. What are the issues? As we begin to look at the issues, the first and primary issue is that systems engineering is not connected up. Look at these guys on the pole. Everybody's climbed successfully to the top. They're all up there ready to go to work. But what do you notice about that pole? It has no wires. It's not hooked to the grid. It's not prepared to empower anything because they're not connected. They're not hooked in. Because they're not hooked in and connected in the ways that they should be, they're not empowered. Often, as we said, the systems engineering functions and systems engineering groups are bogged down in cataloging and managing the documentation, and they're not empowered to do their jobs in the optimal way. For that reason, they have a limited impact. Their ability to impact the organization is minimized by the fact that they're not connected and they're not empowered. But the potential is great. And so the webinar that we're presenting today is designed to plant the seeds of the idea that there's a great potential here and that model-based systems engineering holds an avenue through which that potential can be realized. Anybody who's been involved in systems engineering knows that you have two sets of issues. You have the obvious issues, the above the water issues, and this is a picture of an iceberg, and everybody's familiar with the concept that only the tip of the iceberg shows above the surface of the ocean as the iceberg floats with a great mass beneath it. In the same way, the tip of systems engineering shows. We know about requirements typically, we know about the components of the system that will be designed, and we know about the documentation. And very often we limit our systems engineering practical functions to those obvious areas. But there's so much more going on that really falls under the purview of systems engineering. And you can see below the waterline a list of just some of those things: constraints, traceabilities, risks, decisions, verifications, and on and on. So all of these are kind of out of sight, but all of them have potential for management through your systems engineering functions. The biggest issue is connection with the organization. How do we connect our systems engineering function? Systems engineering organizations are very commonly underutilized. As we said, they're not used for the purposes of coordinating, of going below the waterline, of fulfilling the responsibilities for all those functions that are kind of out of sight in our concept of systems engineering. Where we are leveraged, typically we're leveraged for documentation and auditing, keeping the records straight and reporting on what's in the records. We'll talk about some of the reasons for that. Some of the situations or scenarios in which you might find an under-leveraged systems engineering function occur when you have a capture team looking at the potential for some business and the potential for a solution. Often the capture team functions without the benefit of much, if any, systems engineering. Not very often do we go into the problem and engage systems engineering in modeling the problem or constructing a coherent view of what the problem is that we're trying to solve. So the capture team is working without systems engineering services. That becomes particularly dangerous because in formulating the way that they're going to approach the system problems, they have a tendency to dictate a solution by the very way in which they structure their approach. And so the failure to involve systems engineering from the very, very beginning limits the engineering choices down the line because we've already chosen a solution or a category of solutions. Another scenario occurs when we get into the project and we discover that the schedule that's being represented by the project management is not consistent with the systems engineering plan. We've all been exposed to that, and we all know what happens. You wind up butting heads with the schedule, with the realism of deliverables and the realism of the schedule itself. Once again, that happens when the schedule is constructed by the project management without benefit of the resort to systems engineering services that can coordinate and synchronize. Another scenario is where the test and evaluation plan on the back end of the process doesn't address a critical function of the system. Very often we find that we have a situation where test and evaluation is given a set of documentation that attempts to describe the system. And so test and evaluation is testing what they have seen from the description that they have, rather than testing the actual system or the actual system model. One of the strengths of model-based systems engineering is that test and evaluation, verification and validation are a built-in part of the process, and that the testing that goes on tests the actual model. The other feature of a model-based systems engineering process that copes with this is the fact that the testing goes on throughout. It's not simply testing at the back end. So what are the results when you're in this situation? What are the results of having a systems engineering function that's not engaged at critical junctures in the process and is not fully engaged? One is that the organization and the systems engineering function is not empowered to influence the ultimate solution in the best way that they possibly could. In addition, and because of that, the systems engineering functions don't have as much impact as they could possibly have. So we're sacrificing the level of impact by not involving them. And the impact that they do have often lines up to be impact in hindsight. Now it's time to call in systems engineering. Let's see how we can fix this scenario. So, for instance, once the capture team's done its work without the benefit of any systems engineering, then the systems engineering team might engage and try to deal with what the capture team has done in the way of defining the system solution. This means that program management also is not as productive in conversation with systems engineering. because we don't have that connection and that engagement. We don't have the good conversation. The result for the systems engineering organization is something that we've mentioned a couple of times already, and that is we wind up managing documents, but not really impacting the process. We're busy, but we're just not effective. So where is this influence? Where can we provide the guidance? Where can we influence the process? Where can we actually influence the outcome? Here's where we begin to talk about model-based systems engineering. And I promised you a simplistic overview, a simple overview. And here it goes. First, we're talking about model-centric systems engineering versus document-centric. In document-centric systems engineering, we would construct documentation which would describe various aspects of the model and kind of pool that documentation together and say, okay, the model is the result of the sum of all of this documentation of the model. In model-based systems engineering, you're actually constructing a model, and we'll talk about what that model is, but we construct a model, and the center of the process is the model rather than the documentation. It's based on relationships. These relationships enable us to engage in thoughtful traceability. All of the entities that we'll talk about in a minute, all of the entities are related together, and you can track requirements through behaviors, through architecture to the verification and validation and back again. So all of the elements have relationships. The representations become meaningful output. They're not input, they're not the model. They're simply meaningful output that comes out. A representation can be thought of as an answer to a query, much the way a structured query in a pure database brings you back a portion of the information in the database. The representations are designed to bring out information about the model as opposed to define the model itself. And then the very powerful possibility of simulation. The model's executable. By executable, we mean you can step through the logic. You can go follow the logic step by step. And this can lead to dynamic decision making because you can see if the model breaks down at a point, you'll know because you can't step across it with a simulation. If there are better ways to do it, those very often emerge as you simulate. As we said, model-based systems engineering is a simple concept. It would probably be more accurate to say that it's based on simple concepts. But there is something very zen about model-based systems engineering. First, it's based in entities and relationships, and we'll talk about what those are. But you simply have the entities that make up the system and all of the relationships between the entities. Model-based systems engineering allows you to start anywhere and iterate out to the system design. You can begin anywhere you need to begin, and you can iterate and move to a finished design. And documentation is the output. You don't need to worry about, do I have this representation, do I have that representation, do I have enough representations to adequately describe the model. The documentations in model-based systems engineering are the output, so they flow out of the model as you're designing and once you're finished designing. Vendors have a tendency to try to make all this a lot more complex than it needs to be, but it's really based on these very simple ideas. So let's talk about these concepts a little bit. These are the fundamental concepts of systems engineering. The first concept is the concept of an entity. Let's take a targeting pod. Say our system is this targeting pod. It's made up of things. It's made up of objects or items, you might call them, that are put together to make the targeting pod. For example, a sensor is one of those. You can see the sensor out on the front of the pod. So we would have an entity called a sensor as we begin to model this targeting pod. Now, the sensor has attributes that describe it. These attributes, there can be lots of attributes, size attributes, range of the sensor might be one. The sensor has a cost, for instance. Can be an attribute. And these attributes are expressed in our model. They're one of the concepts of the model. So you can see down there highlighted in yellow the cost of the sensor, an attribute linked to that particular entity. There are also relationships. In this instance, the sensor is built into the targeting pod. So you see this beginning of a representation of the targeting pod system indicates that there's a sensor and there's a signal processor. And both of these are built into the targeting pod, which is the overall system. The relationship of being built in is one of the attributes of the entity, the sensor. And that all put together as a total of all the relationships and all of the sensors begins to make up our system, the targeting pod. Now that's the essential power of MBSE. It rests on that, entities, attributes, and relationships. Of course, it can be much more complex than just this targeting pod with these two entities. You can use these relationships and entities and attributes to build a much more complex system. But these simple concepts become a way to manage the complexity as we scale up to much more complex models. The model-based system engineering methodology allows us to decompose requirements. We can get in and within the model, the requirements are a part of the model. We can decompose the requirements. We can analyze them and come to understand the requirements. We can define the behavior. And again, notice that we're just using these simple concepts to do this. We can define the architecture. Just as that sensor that we just talked about is an entity that's a part of the architecture of the target pod, becomes a part of that definition. We can design the verification and validation. We can look at the requirements and look at the behavior and the architecture and make decisions about how we're going to verify and validate the requirements all the way through behavior and the architecture and back again. We can execute trade studies. So these simple concepts leverage our understanding and our ability to communicate about the system. The model-based systems engineering approach integrates all of the domains into a single model. There's not a necessity to, using an integrated model, there's not a necessity to go out and develop a requirements model and a behavior model and an architecture model. And as you make changes in the behavior domain, you have to remember what they are and move over to the architecture domain and think about making changes that reflect the changes that were made in behavior. You're working with one model. Sometimes it's useful to think of the domains as windows into this model, as ways of looking at the model. So V&V, verification and validation, are there. The requirements, the behavior, the architecture are all there. And the basic relationships are that your requirements become the basis of your behaviors. Your behaviors are based on your requirements. Your behavior is allocated to your architecture, and your architecture performs your behaviors. And then all of this is verified and validated back through the model and traced fully back to the requirements. Documents are automatically generated from the data in the repository. The documents and views, graphical views, documentary views are all pulled as responses to queries of the model. So they flow out of the model. They don't define the model. They don't become the model itself. They represent the model, and they flow from the model. And they're chosen because they represent a subset of the information that answers the questions that you have at the moment you choose them. The value of the methodology is that it gives us formal system specifications. We can go all the way to creating the system specifications out of the model. It allows us to perform comprehensive risk analysis. It allows us to capture the trade studies that we've done as we've made design decisions along the way. It becomes a single repository for maintenance, so we're not sneaker netting things around. We don't have different models. We don't have different sets of documents to port from one to the other. We can version records and the database metrics as we go and keep all those in one place. So all of these work products that we can get, all of this value that we get is founded on the discipline approach applied by the systems engineering team. It allows the engineers to focus on engineering and not on document production. Another big value of the methodology is that it synchronizes our activities. We're able to fly as close as we need to fly because this synchronizes and puts us in relationship with all of the activities that we're performing. Model-based systems engineering has impacts across the whole organization. It affects the entire team. It puts the entire team onto the same page. Everybody working together, everybody achieving and driving toward the same goal. We can identify risks earlier and deal with them. The models have the value for us, so we're able to obtain those values that we just talked about and make all of that available to the entire team. We're able to control our costs. We're able to see what the impact of changes are going to be going down the road. The whole team is in sync as we engage in the model-based systems engineering approach. It also reconnects us with the organization. It connects the power of the systems engineering back with the organization. It connects with program management and communication. We're able to give program management a window into the design and a way to have impact back and forth in that conversation and communicate. It reflects the program cost and risk. It allows us to integrate with the product development. And by integrate, it means integrate the entire organization so that we have this insight, which gives us some transparency into what's going on. It's not as if the separate functions have taken their functions and gone to their own corners to do their work and come back and report. And it feeds test and evaluation. So we don't have that scenario where we get to the end and we construct a test and the test really doesn't test the system that we've designed. It tests the system that the test team thought we designed. Now, in reconnecting, it makes it easier to attain our cost performance. We can look at the cost performance by looking at the model. We can determine where's the thresholds and limits are as we look to get what's called on this chart the best bang for the buck. It shows us where we are. It shows us what the effect of the changes are going to be, because we're able to look at the sensitivity of threshold values. Risk is a big item from an organizational standpoint. We want to know what our risks are. We want to know that as early as we possibly can. We want to know how to mitigate it effectively, and we want to understand the dimensions and the likelihoods of the risk. Simulation is a very powerful tool to reveal right where our risks and weaknesses are. We're able to construct mitigation plans that can now feed the analysis of our alternatives as we go forward. And we can track the costs of the mitigation plans by knowing what our implementation is and how it's changed. It impacts product development. We see what are the costs of compliance strategies. We're able to see what the impact is going to be on the platform design. How is this system going to be able to interface? Do we need to make any changes or adaptations in the platform as we go forward? And it feeds test and evaluation with all this kind of information. In summary, systems engineering should really be about impacting the outcome. It should not be limited to just managing the documents. Systems engineers should not be librarians. They should be problem solvers. This value model is the engine that empowers systems engineering teams. If we're able to impact the design in ways that add value to that design, that cut our costs, that manage our risks, that improve the design, then that's the engine that powers our systems engineering teams. We exercise the model as our value proposition. We can use that model for simulation to look for risks, for example. So we're able to use the model in a variety of ways. We connect to the organization through logical decision-making processes. The organization can see the design choices before us. They can see the trade studies. They can see the work that's done. They can see the reasoning behind different decisions that drive different design choices. And we can become more aware through the sensitivity of the constraints kinds of analysis of what's driving our cost awareness. We become an empowered team through the use of model-based systems engineering. So we're not climbing a pole that's not connected to the grid. We're not climbing a pole with no wires on it. We're actually doing real work, problem solving, and we're not simply managing documents and serving as the librarian to the systems design. Here at Vitech, we have a variety of model-based systems engineering solutions to offer you. We've been delivering those to customers in the government arena, in the military arena, to private business, to publicly traded companies, to universities, just a wide variety of clients since 1992. We can offer software and support for the software. We offer professional engineering services to help you solve those particularly hard problems or to deploy and implement this approach. We offer model-based systems engineering training to bring your team up to speed so that you can leverage these advantages. And we also engage in a good deal of research and development ourselves. Our methodology, our tools, our approaches are always evolving, and we're always happy to offer the very latest that we have to offer. I appreciate your registering today, and I'll turn this back over to Bethany, and I certainly would welcome any questions or comments that you might have.
Thank you, Zane. We've had a few questions for you today. Our first question is from Reed, and he asks, how does MBSE work in an Agile or Scrum methodology?
We've done some looking at that, and in fact, I did a webinar several months ago called More Agile Than Agile. In an Agile environment, the model-based approach married with the Agile allows you to be responsive in the way that an Agile approach wants to be to changes. If we were to drive particularly into the strata methodology, we proceed layer by layer. And what we bring to the Agile team is that system view, because our layer starts at what some Agile folks call spin zero or layer zero. We offer that systems view so that the tasks that get fed into the backlog are the right tasks for Agile developers to work on. You know, the fear that you always have with an Agile approach is that, oh my gosh, we're going to go out here and we're going to develop this and we're going to develop that, and the day of reckoning is going to come. We're going to have to hook all that together. Exactly how's that going to happen? Well, if you were to combine your Agile approach with the model-based approach, you would maintain your system view and keep your responsiveness. So I think there are some real possibilities there.
Thank you, Zane. I knew that was a perfect question for you. I'll just go ahead and remind everybody, if you have a question, we still do have a chance to get it in. You can use the question panel inside the GoToWebinar window to send that to me. And while we wait and see if we have any more, I have one more question for you, Zane. This is from Joe. And Joe asks, why do you say that documents are the output of the model?
I said that and said it several times simply because I think there's so much confusion about that. You have folks out there who would have you believe and have fallen into the trap of believing themselves. If you have a robust enough set of views, then you have a model. But when you think about what a view or a document, a set of specifications is, it's a subset of the information in the model, a subset of the information about the system you're designing. It's a response to a query. So if you put together a view, say an activity diagram, you're going to make a SysML activity diagram. So the way that that's done in your tool is that you structure up a query that goes and gets all of the information needed to put into the diagram, and then it constructs the diagram according to the rules that are defined for that and presents you that information. That's the same basic process that happens if you ask the model to give me a list in Word of all of the requirements. It simply looks for all the requirements, puts that information together, and then structures it up using the rules for Microsoft Word in that case to present that information to you. So your documents flow from the model. They're not the model, and you don't do all the documents and say, okay, now I've defined the model. You use the documents as the output. That's very helpful, incidentally, because you don't spend time worrying, do I have all of the documents that I need to define this model? Do I need more documents? Are my documents accurate? Your documents are always accurate. Why? Because they came right out of the information, and they're as good as the good information that you put in there.
Thanks, Zane. One more question for you, and then we'll probably wrap up. Another question from Reed, and he asks if you could address the various modeling notations that are out there. He said, it's a little confusing with SysML and UML. Asks if we have any recommendations, and especially if you have a new team that's not very well versed in MBSE.
We have we offer a wide variety of views and representations, including the SysML representations. What I would say up front, and Sandy Friedenthal makes this point in his book, that those representations are independent of a particular methodology of constructing the information that goes underneath them, the model that goes underneath them, if you will. It's important to remember that the representations are just that. They're not the system itself. Now, when you start talking about a language and a set of diagrams becomes a language, then that's where, and I understand why that's done, but that's where you kind of skate out onto the thin ice and the representation starts to become it. So the ideal situation is you want to have as many alternatives available to you to make the representations that you want to make. If you're gonna give a presentation to a business process owner about the model of the process that they own, most of the time you'll find that one of the most effective ways to do that is to show them an enhanced functional flow block diagram, an EFFBD, because they're used to seeing diagrams that flow with a process through boxes from left to right. So they understand they can follow the process through, and that happens to be the best representation for them. Show one of those guys an n-squared diagram, and you're going to have to do a lot of head scratching and a lot of explaining. So we don't really recommend one particular way of representing things as the best, simply because the best is defined by your situation.
Thank you, Zane. I should have known better than to say that was the last one, because I have at least one more. Questions are getting very vibrant. I thank everyone for the questions. The next question is from Hongmen, and the question is if you could touch on the scalability of both MBSE tools and MBSE methodology. How successful are organizations in terms of deploying MBSE to large-scale projects?
Scalability has really not ever been an issue for this. Back in the presentation, I said one of the powers of it was that you could begin anywhere you wanted and iterate outward. In today's world, we're finding that what we have called middle out representations are becoming more and more the rule. In other words, if you're going to go, and I came from the process world, if you're going to go in and improve somebody's process, you're typically not going to be invited in by the organization and given a blank check to throw away all their technology and to make any kind of modifications to their surrounding processes that might be touched by the one you improve. So you're able to begin in the middle of things. I participated in a project for a government client where we were modeling into a very large process, and the way that we were doing it was by attacking it through the processes and sub-organizations. So we were able to model this piece of the process and then model to another piece of the process that hooked together, and then hook the two together and model them into a larger process. So scalability and complexity is really not an issue for either the methodology or for the model. The size of the model, I suppose, is limited, although I've never come up against this limitation, is limited by the size of the equipment that you have for a single repository model to live on.
Thank you, Zane. I'll let you off the hot seat for now on questions. If you have a question that you posted and we did not reply to it or did not ask it out loud, we will contact you after the webinar directly to make sure that your questions are answered. So again, Zane, I thank you, and thank you to everyone who attended today. A recording of today's presentation will be available on our website. That's vitechcorp.com. Once you're there, click on Services and then Video Archive. If you'd like to continue the conversation, join us on our community website, and that's community.vitechcorp.com. Thanks and have a great day.